In the previous lesson, you learned how to create a visualization on RAWGraphs. You learned how to design, edit and download a scatter plot, which is a dispersion model, meaning that each point represents a row of data. In this lesson, we are presenting other families of visual models: dispersions, hierarchies, time-based, and distributions. The choice of the visual model depends on data and on the communicative purposes of the visualization. If you click on Try our sample, you see that each of the provided dataset has a subtitle indicating the kind of visualization it is most suitable for. In the previous lesson, we worked on the movies dataset. If you look in the interface, you can see that the dataset is suggested for dispersions. For this reason, we decided to design a scatter plot. After choosing or uploading a dataset, you will see the grid of visual models. For each one, it is possible to see the belonging family. The first 5 visual models are dispersion models, including the scatter plot and the contour plot. The contour plot shows the estimated density of points clouds, which is especially useful to avoid overplotting in large datasets. If you try to replicate the same actions done for the scatter plot, the contour plot will appear. Therefore, we map production budget as X and box office as Y. You can change the appearance from stroke to fill and set the color scale as linear. And then you can download it, as you learned in the previous lesson. Hierarchic visual models are useful when you want to visualize nested data layers that could be weighted or not. Going back to the sample dataset, the Animal Kingdom dataset contains information on the scientific classification of the animal kingdom, which is hierarchical and non-weighted. The dendrogram model is the most appropriate because it shows the whole hierarchy. In this case, when you are mapping dimension, there's only the hierarchy variable, where you need to drag and drop the dimensions in the desired hierarchical order. For example, the hierarchy from the biggest group, kingdom, then phylum, class, and so on to the smallest one, name, which are the names of all the species. When you're dealing with weighted hierarchies, there are other visual models you can use, such as circle packing, sunburst, or tree map. For experimenting with one of these visual models, you need another dataset. Among the sample dataset, one of them, the Orchestras dataset, is a weighted hierarchy. Indeed, it shows the number of instruments belonging to different groups in orchestras. If you click on a tree map, you can map the hierarchy as in the dendrogram. Therefore, type, group, and instrument. If you drag and drop the number column in the size variable, you will see areas changing. You can also use color for better highlighting orchestras type. Okay. When dealing with data changing over time, it is necessary to use another family of visual models, the time-based visual models, time series and time chunks. A time chunk visual model is a Gantt chart in which you have a starting and an ending point in time. Let's take the example of the evolution of Iron Maiden band. For each member, we can see when he joined and left the group. A second kind of time-based visualization are time series. You can choose between RAWGraphs, a series of small, similar RAWGraphs along time that allow comparing the evolution of different groups of data, horizon graph, combine position and color to reduce vertical space, bump chart, and string graph. In all these models, the horizontal axis represents time, but different visual strategies are used to represent quantities. We can use the music industry dataset to create a bump chart. It illustrates the evolution of market share and media supports over time. Rows represent the annual market share of each media. Be careful, pay attention to the format in which you enter the date. Some of them are not supported. For further information, you can go to this link. Once the dataset has been uploaded, you can choose the RAWGraph visual model. For mapping your dimension, you need to drag and drop the media column into the group window, the date, and the market share as size. And if you want, you can assign a color to each group. One of the peculiarities of this group of charts are the interpolations, namely, the way in which points of each curve are connected, which can be more or less approximated. By default, the density design interpolation is selected, which is quite accurate. Another interesting family is composed by distribution visual models. These models show how data points distribute in a range according to different categories. Beesworm and boxplot are the most widely used. The beesworm shows the distribution of data points according to one variable, avoiding overlaps between them. You can try this using the Titanic passenger sample dataset. For instance, for visualizing the age distribution of Titanic survivors divided per gender, you should drag and drop the gender column into the group variable. Use age for x-axis, which encodes the distribution ranking, and then color accordingly to survival or not. Remember that a beesworm plot uses forces to avoid collision between the single elements of the visual model. While this helps to see all the circles in the visualization, it also creates some cases where circles are not placed in the exact position they should be on the linear scale of the x-axis. In conclusion, in this lesson, you learned that there are different families of visual models in RAWGraphs: dispersion, hierarchies, time-based, and distribution. You have also learned that they have different communication purposes and that they need different data format. For discovering other families, you can have a look at the learning section of RAWGraphs.